Welcome to a tutorial of ProfLearn YouTube channel. In this particular video, we are going to have a discussion on how you can be able to work out different questions to do with the mechanics. Remember, if you are going to join A-level AS, one of the units that you do if you are taking physics is mechanics. It's optional. You can do statistics 1 and statistics 2 in Edexcel A-level math, but for those who are taking physics, this is the best unit you can be able to do. So we had started looking at part 1 on how you can be able to work out questions to do with this unit. And this is the first topic, mathematical modeling and vectors. So we're going to have a detailed discussion on how you can be able to approach different questions, how you can be able to work them out, so that whenever you are going to be given exams and when you'll be doing your mocks, you'll be in a position to answer different questions. And if you're new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload further tutorials, you'll be notified. If you want to access this PDF that you can be able to see I'm having here, consider joining and checking into our Patreon page so that you can be able to be in a position to download this PDF. Now let's dive in and get started on how you can be able to approach different questions. Since we had in part 1, we had looked at how you can be able to find the speed when you're given a velocity vector like that. And then now we were to move to question 2. And in question 2, these are two forces which are acting in opposite direction. And the angle between the two forces is given here as 150. And then if we want to find the resultant vector, you can be able, the resultant force, we can be able to complete the two diagrams, the diagram, so that we can be able to obtain the parallelogram in that case, and this is going to enable us work out, because this force is pulling this side and this force is pulling this side, the resultant force will be acting in that particular direction. So that means that since we were told in this question that the resultant force is has a magnitude of 129 root 129, so you can be able to say this is root 129, and if you have this angle, we can be able to say this angle here is equals to also 30 degrees. So that's what we are going to consider. And in order to find the value of x, and of course if this angle is 30 degrees, this angle is also 30 degrees. So which means we can be able to use the properties of a parallelogram in order to work out this. So using this angle that we are having here, we have this side. If this side is 5 root 3, also this side is 5 root 3. Yeah, so we have to remember that. Now, in order to work out this, we are going to use cosine rule. You can be able to use cosine rule, or you can be able to use sine rule in order to work out this. Now, how do you use sine rule? For instance, this one, we are going to say, if first we may want to know what this angle is. We want to find this angle. If we use sine rule, I want us to apply opposite sine to beta is 5 root 3. 5 root 3 is equals to, I'll use now sine 30 divide by the opposite side is root 129. Yeah, so we have that, which means that we can be able to say that sine beta is going to be equals to 5 root 3 sine 30, which is divided by root 129. Yeah, so if we put this in the calculator first, in order to reduce that, we are going to say this is 5 root 3 root 129 sine 30, which is going to translate to sine beta is going to be what? Is going to be 0.3812, which means that beta itself is going to be sine inverse of 0.3812, and if you work out the sine inverse of that, you are going to get the answer. In that case, is going to be 22 degrees, 22.4. So which means that this angle that we have here is 22.4. Yeah, so we can be able to find theta. Yeah, you can be able to find theta. Let me just reduce this so that we can be able to have just enough space whereby we can be able to work it out. So we can say theta is equals to 180 minus into bracket 22.4 plus 30, which is going to be what? Which is going to be 127.6. Now, which means that this angle is 127.6. What does that mean? It means that we can be able to use again sine rule in order to find the opposite side, which is equivalent to x. So therefore, at that point, we can again apply sine rule. And in that case, we are going to say this is going to be x over sine. Sine of opposite side to x is 127.6. Sine 127.6 is equals to root 129. Root 129 over sine 30. So which will imply that our x is going to be equivalent to x is going to be equivalent to what? Is going to be equivalent to root 129 sine 127.6 divided by sine 30. And if you work it out, this is going to be equivalent to 1. This is root 129 sine 127.6 sine 30. Oh. Sine 127.6 sine 30 times square root of 129, and that translates to 17.99 to two significant figures. This is going to be 18 newtons. 18 newtons. So that's what we were supposed to do in that particular question. So when you are going to do mechanics, remember you are going to use the rules of cosine, sine rule. You find questions to do with that. Now the angle between, what's the angle between Q and the resultant force, the angle between Q and the resultant force. How to go about the angle between Q and the resultant force. So which means that we can go back to the diagram. Q and the resultant force. Q is this side. So which means if we have this angle here as 127, okay, the best way we can be able to work it out, let's consider this angle that we have here. So which means if we want to find this angle here, we can be able to say 180 minus 22.4 minus 30. Let's check what does it give us. 180 minus 22 minus 22.4. You have to be very careful so that you can be able to find the expected angle. You don't make a mistake at that given point, yet you can be able, the angle that we want is this angle. But remember, we already have this angle here, and also we have this angle. So meaning if we consider this as a straight line, we can be able to work out that angle. We can say this is 180, and we shall subtract 22.4, and then we subtract 30. Let's see, and let's check what it's gonna give us. 180 minus 22.4, then minus 30, which is going to translate to 127.6 degrees, 127 degrees. So that's what we are getting at that point. That's what we are getting at that point. And if you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. So let's just continue. Let's continue working, guys, on this particular tutorial. So, and if you have not accessed the PDF of this tutorial that I'm having here, consider checking in the description. There's a link that is going to take you straight to where you can be able to download the PDF. And I wish you the best of luck as you are joining A levels. Yes, so I'm trying to see if I can be able to access this PDF and see if you can be able to see it in our Patreon page. Yeah, in the Patreon page, I've included everything that you need in this PDF, because you can be able to access the solution of each and every question. Yeah, so which means that if you are giving your answer also, you may consider giving your answer correct to 3 significant figures, and that can be given as 128 degrees as well. Let's go to question number 3, and let's see what is expected in this question. A particle A of mass 0.5 is at rest, and then we are having two forces which are acting on this. Given that A moves in the direction of this particular vector, then we are supposed to show this. So if an object is going to move in a particular direction, it means the force, the force will be acting in that particular direction that we are having. So which will mean that this guy and this force, the resultant force, due to the effect of these two forces, they are going to be acting in the same direction. So we can be able to apply the rule of parallelism. So we can be able to say the resultant force and the direction of that vector, they are the same. So in order to work it out, first let's find the resultant force. Resultant force. If you are given two forces acting on an object in mechanics, you are going to say resultant force is going to be, the sum of the forces, the number of forces that you are given. So in this case, if we are having F1, then we're going to add it to F2. You just add the forces. Then in that way, we can be able to say this is going to be minus 3I plus 2J plus PI plus QJ. Now with this, we are going to add those forces which have the same components. So for instance, you are going to add I to I and J to J. So this is going to translate to P minus 3I, because if you say negative 3I plus PI, that's going to be P minus 3I. And then we shall also have this as plus 2Q 2 plus Q, and this is our J component. Then once we have this, we can be able to say this resultant force and this component that we have here, they are parallel. Then we can now be able to apply ratios in order to work out the value of P. So if we find the ratio of their components, since they are parallel, we can be able to say P minus 3I over 2 plus Q for this part should be equals to 1, because this is just I, 1I over negative 2. So this is the ratio that you are going to use in order to show that because they are parallel, so we are going to form an equation using the ratios that are using the ratios. Then we can be able to cross multiply. In this case, if we cross multiply here, we shall have 2P minus 6 is equals to 2 plus Q. If we're gonna put the like terms together, or we just take all the terms on one side, we shall have 2P. Okay. Yeah, so I think I'm not taking care of the sign properly. Those are the kind of areas that you need to be very keen, because if I multiply here, cross multiplication, we shall have negative P, 2P plus 6 is equals to 2 plus 2 plus Q. So if you rearrange this, we are going to have 2P plus q minus 4, which is going to be equals to 0. So basically that's why you can be able to see we were told to show this. Now, given that p is 5, find the speed of a at the time t is 4 seconds. So if p is 5, it goes without saying that we can be able to find what we call if p is 5, we can be able to find q using this equation that we are having here. We can be able to say 2 times 5 plus q minus 4 is equals to 0, which is going to be q is the equivalent to what? Is going to be equivalent to minus 10 plus 4. Tell me bless you. So this is going to be negative 6. Negative 6. So meaning we can be able to find the resultant force. We can be able to find the resultant force. And if we have the resultant force, let's first substitute the resultant force. The resultant force is going to be F resultant is going to be 5 minus 3 I plus 2 minus 6 J, which is going to translate to 2I minus 4 J. Yeah. So this that we have gotten here is basically the resultant force. Then we can be able now to use the formula. Force is equals to mass times acceleration, and this is going to enable us know what the acceleration is. So it will be 2I minus 4J is equals to 0.5 times our acceleration. So if you work it out, or you divide by 0.5, you divide by 0.5, it means that every element that we are having in this particular question will also be divided by 0.5. So which will mean that our acceleration will be 4I minus 8J. This is the acceleration. Now let's go back to the question. A particle of mass is at rest. So which means that the initial velocity was what? 0. Yeah. And that will mean if you are going to use the equation v is equals to u plus at, we can be able to work out the velocity after the time 4 seconds, which is going to be 0I plus 0J time is 4 times the acceleration, but the acceleration in this component is going to be given as 4I minus 8J. So if you are having this acceleration in unit vectors, if you want to proceed the next question with the magnitude, you can be able to find the magnitude and you get the exact value of acceleration, or you can work with it and then find the magnitude later. So another student in another school could have just come and say, all right, so my acceleration magnitude now will be the magnitude of square root of what? 4 squared plus negative 8 squared. And this student will get the exact magnitude as 16 plus 64, and that is going to be equivalent to 8.94 meter per second square. This will be the exact magnitude, or you can just work it out. The way it is, you work out, you get the velocity, and then proceed. So the velocity is going to be 16 minus 16I minus 32J. And now if you want speed will be equals to the magnitude of the velocity vector, which is going to be square root of 16 squared plus negative 32 squared. And what does that give us if we work it out? That is 16 squared plus, then we find the square root of that, which is going to be 16 root 5, or which can be given as 35.8 meter per second. So that's one way you are going to deal with this. Or you could have just worked out the acceleration, yeah, and then now once you have the acceleration, you can come and say velocity is going to be equals to what? 0 plus 4, because the time was 4 seconds, times 8.94. So if you take that 4 times 8.94 is going to translate to what? 35.76. Yeah, 35, yeah, 35.76, which is typically the same. Yeah. So let's look at question 4. Quite interesting work that you're going to do in A levels. Let's see question 4. What does it have in store for us? Yeah, so if you're new to ProfLearn YouTube channel, consider subscribing, and also consider checking our Patreon page so that you can be able to access the PDF of this work that I'm just showing here. All right, so let's proceed and look at the main and the important part as to why we are here. Two ships, A and B, are moving with constant velocities. Yeah, the velocity of A is that here 3I plus 12J, and the velocity of B is Pi plus Qj. Find the speed of A. I've said speed is obtained by finding the magnitude of velocity. If you are given velocity, then you are asked to work out the speed. You need to work out the magnitude of that velocity that is given. And the magnitude of this A is going to be 3 squared plus 12 squared. And if you just plug that into your calculator, you're going to say this is 3 squared plus 12 squared. You're going to get a very beautiful answer here, which is basically 12.37 meter per second. That becomes the speed of this. Then let's look at part B. we are given the information that the ships are modeled as particles. 12 a.m. or 12 noon, sorry, the position vector A is at the position vector this at 12. B is at the point with the position vector that. So they are observed at the same particular time. At time t after 12. So which means if they are in a given position, after some time, they are going to change their location. Yeah, they are going to move from wherever they are. Find after that particular time, they are this distance apart. So what will be the position of A after t seconds? So we can be able to say the position where will be A after t seconds is going to be at which point? Remember, A was at the point -9 I 6j. So it will be at -9 I plus 6j. Yeah, so this is the position at 12 noon. Then we're going to say that's going to be plus, because we know displacement is speed, displacement is velocity times time. Yeah, so if we are talking about displacement is velocity times time. So if we take the velocity of A times the time, we are going to get the distance that ship has already moved. Then once we know where the distance it has covered or the displacement it has covered, then to know its position, we are going to add where it was, the place where it was originally. So this is going to be the speed of A. The speed or the velocity of A was 3I plus 12j. So we're going to say this is 3I, which is the speed, the velocity, plus 12j. And this is multiplied by the time after the time t. You need to remember that. Then we need also to look for the position of B after the time t seconds. But we have to consider where it is currently. This currently is at the point 16I plus 6j. So currently it's at 16I plus 6j. Now after some time it will have moved some displacement. So in order to find the new position, now we have to add the displacement that's covered after some time. But remember, we were not given its velocity. It was pi plus qj. So we are going to say it is going to be pi plus qj, and this is going to be after the time t. Okay, so if we are finding AB, that is going to be the position vector of B minus the position vector of A, and that is going to translate to -9I plus 6j plus 3I plus 12j minus I've written this wrongly. For us to find the position vector of AB, it will be B minus A. So that's going to be 16 I plus 6j plus pi plus qj t, and then we're going to subtract what we have here as negative 9i plus 6j yeah, then plus 3i plus 12j and close the bracket 3, and that is it. So basically that's what we are going to do, and once we do the subtraction we are going to equate to, because we were told is equals to this, we are going to equate to this particular part that we have here. So what I'm going to do here, I will reduce the font, and then I can be able to work out the simplified first expression of that, and then we are going to solve the two equations. Now if I open the brackets here, and this is going to translate to if you work out everything here, this is going to translate to what? It will be 16i minus pt plus shall have 25 plus p minus 3 into t, that is going to be equivalent to 25 minus 12t minus 12t. So you can see here 25 and 25, so which means there is kind of misbehaving here. So which means that if this is 25 and this is 25, so and we have a t here and a t here, so it means we can be able to equate this part to 12. Yeah, so it goes without saying that we are going to say that p minus 3 is going to be equals to minus 12. Yeah, so our p is going to translate to what? Our p is going to be minus 12 plus 3, which is going to translate to negative 9. That is p. Our p is going to be negative 9. Yeah, mark that. Then let's look at q. If you look at this equation that we're having here, we can be able to write this as q minus 12 into t. Yeah, because if you factor t out, you are going to remain with q minus 12. Yeah, so that's quite important. Q minus 12 into t, and that is the j component, is going to be equals to negative 9t as well. So it means that we can cancel t's, and we shall have q is equals to 12 minus 9, and this is going to translate to be 3. Our q is going to be 3. So basically that's what we are going to do. It was quite an interesting question, but finally there we are with the value of q and this as the value of p. P can be written in a better way. We can do better. -9, and this is -3. Now, find the bearing of A from B when the ships are 15 kilometers apart. If they are 15 kilometers apart, what's the bearing of A from B? We shall go back here. Let me just show you. In this particular part here, we were given that displacement, this is the general displacement between A and B is 25 minus 12t minus 9tj kilometers. So, but in this case, we are focusing on 15 kilometers apart. So, which means if we use 15 kilometers, with this part that we have here, we find the magnitude of this displacement, which shall equate to 15. So this is a displacement vector. So if we find the magnitude of that, we equate to 15, it's going to give us what we call the displacement, which is 15. But if we work it that way, it will enable us to work out the time taken. So we shall say square root of magnitude of this that we are having at this point. We are going to say this is going to be 25 minus 12t squared plus -9t also is squared, is going to give us the displacement, which is 15. Then to work out that, of course, we're going to square both sides, and this is going to be 25 minus 12t plus -9t squared is equals to 225. Yeah, so because if you're going to square 15, we're going to get 225. Now you are going to square both sides as well, those expressions that we are having there, which is going to enable us form a quadratic. So this is going to be 625 minus 600 t plus 144 t squared plus 81 t squared is equals to 225. If we're going to put the like terms together, in this case, we shall say 144 plus 81. That's going to translate to 225 t squared. And this is going to be minus 600 t. And of course, we're going to take this on the other side of the equal sign, so it will be 625 minus 225. That's going to translate to plus 400 is equals to 0. If we divide, if we divide all through by 25, 25 divided by 25 divide by 25 divide by 25, this is going to be 9 t squared minus 24t plus 16 is equals to 0. So once we have gotten this quadratic equation, the next business we have is to ensure that we are going to solve the quadratic, which is going to give us the value of t. So we can be able to say t is equals to 24 plus or minus square root of minus 24 squared minus 4 times 9 times 16 divided by 2 times 9. If we work this out, just put this in our calculator. Which is going to be 4/3. Our t is 4/3 because that is exactly what we shall have. So our t is 4/3. But we are supposed to work out the bearing. So since AB is the displacement and we need to find the direction, so it means that if the displacement from find the bearing of A from B. AB represents the displacement of A from B. AB is the displacement from A to B, and so this is going to be AB itself is going to be 25 minus 12 times 4/3 I plus, this is minus 9 times 4/3. This is going to be J, and if we work how this in order to reduce it, it's going to be 25 minus 12 times 4/3, and that becomes 9i minus 12j. Yeah, minus 12j. Since the direction, the displacement of B from A is this, it will also mean that the direction, since the displacement of A from B is this, so it will mean also the direction of A from B is going to be in the same direction. So in order to find the angle, we are going to say theta is equals to the tan inverse of 9/12. And if we work out that, we are going to get 37 degrees. So the bearing is going to be 360 minus 37, which is 323. 323 in that particular part. Yeah, so this marks the end of part 2. We shall work on part 3 in the next tutorial. So if you have not subscribed, consider subscribing so that anytime I'm going to upload part 3, you'll be notified.